Hi grade 11s. Okay, so here's everything that you need to know in terms of trig for your people's paper that is upcoming. So you need to know that the basics of trig, if I have a triangle, let's put it on a Cartesian plane like this. I'm going to put it like this. Let's say this is our reference angle theta. Opposite this would be over here. And can you see that this line over here corresponds with the y-axis? So we're going to call this y. This here is our 90-degree angle, and opposite the 90-degree angle gives us a hypotenuse. So we're going to label this as hypotenuse. Okay, it's also, if I had to put my point over here and draw a circle around, this here would be my radius. Okay, and let's write an O here. And if this is theta, this line over here is adjacent to it. Adjacent would be like next to. So this here is my adjacent, or else it corresponds with the x-axis. Then what you also need to know is sine theta. So sine of this angle over here would be y over r, and also opposite over hypotenuse. The reason why I'm giving you both of them, even though for trigonometry I want you guys to only learn this one here, I'm giving you both of them because we're going to be building your knowledge towards something called or known as 2D and 3D trig, right? And in 2D and 3D trig, you need to know that sine is opposite over hypotenuse. We need to know that cos theta is equal to x over r, and that's the same thing as adjacent over hypotenuse, and that tan theta is equal to y over x, which is opposite over adjacent. There's lots of things on the internet, and you can think of stuff yourself on how to remember this. Like, if you're not so good at remembering it, then you can go look on the internet for like keywords and like songs or mnemonics or whatever it is that people have created so that you can remember this. Okay, moving on to, this was grade 10 stuff. Moving on to more of grade 11 stuff, right? What we also learned this year, or what you need to know, is we need to know how to reduce something to an acute angle. So this here is 0 degrees, this here would be 90 degrees, 180 degrees, and 270 degrees, and then full circle again would be 360 degrees. In this quadrant over here, it's already an acute angle, so it's theta. If we wanted to reduce something and it is in the second quadrant, we would say 180 degrees minus theta. Okay, so I'm using basically this line over here, the horizontal line, as my reference line, if that makes any sense, right? This one over here would be 180 degrees, and it's more, so plus theta. And this quadrant over here would be 360 degrees minus theta. Okay, then if I take the same Cartesian plane, let's draw it over here. Okay, 90 degrees. Right? And I use this line over here, so the vertical line, as my point of reduction, right? In this quadrant over here, it would be 90 degrees minus theta. In this quadrant would be 90 degrees plus theta. In this quadrant, it would be 270 degrees minus theta. And in this quadrant, it would be 270 degrees plus theta. However, when we're doing this, it's important to note that when we're using this line over here, our sine becomes cos and our cos becomes sine. Because if you think back of your back to your grade 10 knowledge of trig functions, you would have noticed that if I drew a sine graph and a cos graph, they're like sort of to the opposites of each other, right? And we refer to that as them being co-functions. You can try it out on your calculator. You can see sine 30 degrees and cos 60 degrees. 30 plus 60 is 90. So see the numbers, what it gives you, and you'll see that it gives us basically the same thing. And that's exactly what we're using over here. So if I hit cos, right, cos of an angle, and I use 90 minus, it must become sine of that angle, right? And the same thing, sine becomes cos, right, for each of these. We're going to try an example of each of these. I'm just going through theory for now. Another thing that I need to mention is when we are using the Cartesian plane, in this quadrant, all three of our ratios are positive. In this quadrant, only sine is positive. In this quadrant, only tan is positive. And in this quadrant, only cos is positive. And again, for this year, you can think up of a mnemonic, or you can think up of a word or whatever, a phrase to remember it. Someone said it's known as the CAST diagram, CAST. Someone said all students take coffee. You can think of whatever you'd like to remember it, okay? It's very important that you know this, because when we're doing reductions, you need to know what the sign of each of the reductions are. Another thing that I should mention is negative angles. All right, negative angles. Now there's different ways of working through negative angles. I'm a very methodical person. Sorry, I forgot the word there. And so I like to see methods as to what's happening in my sum. So you can try the same thing, or else if you found a method that works for you, you can use that by all means. What I like to remember is that sine of negative theta is equal to negative sine theta, and I'm going to tell you why in a second. Cos of negative theta is equal to positive cos theta, and tan of negative theta is equal to negative tan theta. And how I remember this, or how I get to this, is a negative angle. So a positive angle would be going in this direction. A negative angle would be going in this direction, right? It's the opposite. And when we end up in this quadrant over here, we know cos is the only one that's positive. There we go. Cos is the only one that's positive. This one's negative, this one's negative, and that's how I remember it. And then when I get from there, then I can then use the reduction and continue. In terms of theory, this is all the important things. I'm now going to make a separate video showing you how to work through each of these kind of questions.